For section 2.6, we're going to solve systems of inequalities. So you pretty much have to graph these because there's a whole region that would be your answer set. So here's the steps we're going to go through, but basically you're going to be looking for this feasible region is the intersection of all the graphs and the overlapping shaded areas. Okay, so let's see what we got here. And we'll get into the bounded, unbounded, we'll talk about that. Basically, like, is the feasible region all closed in or is it open? So we're going to graph each line, graph each linear inequality. Remember some little details like if it's equal to, it's a solid line. If there's no equal to, then it's a dashed line. You're going to lightly shade the solution for each inequality, but where they overlap, make sure you shade that one extra dark. We could always use a test point, but if it's greater than or equal to, you shade above the line. If it's less than or equal to, less than, you shade below the line. So let's show you how this goes. I've graphed on the line just to make my job a little bit easier, but we'll talk about the shaded area. Notice this first one's in the right format, so we just go for it. Starts at -3, goes up 4 over 1, up 4 over 1. The more points, the better, so you can draw a better straight line. Notice I drew a solid line for this one here because it's got the equal to. Over here, it's not ready to graph. We'll get into that in just a second. Let's go ahead and shade this other one here. Let's see, it should be everything less than or equal to. So less than would be below the line, so I would shade like over here. Everything on this line obviously keeps going. Like if I wanted to, I could keep going all the way over here if I needed to. Keep going, keep going. Let's see about the other line. So the other line, I had to divide by -2. So I divided by a negative, that switches my inequality to a less than. And I mean, this is just 1 divided by -2, so I can't really do that. So just -1/2. So how about I start at 0, go down 1 over 2, down 1 over 2. Feel free to even reverse it, get some more points. Notice it's not equal to, so it should be a dash line. This one is also a less than now that I've got the right symbol here. Less than would be below the line, so I would shade over here. And what I'm going to really look for is where would it overlap? And in this case, it looks like it's this area here. So you just make sure that shade the darkest. You kind of already see it's already the darkest area. But if you want to, you can go back with like a darker color and you can like shade it all in here. So everything here. And this would be unbounded because it just keeps going in this direction. Like if I really wanted to, I could do like the point -2, -20 would be a point in this region. And that's the idea here. Any point in here, you can actually plug it back in and see that it works. Okay, so we can always test a point, and we'll discuss that more in class and see how that works. Okay. Next one here. Again, I drew my lines ahead of time to make my job easier. This first one starts at 2, so up here at 2, goes up 1 over 3. It's a solid line. Here's another thing to do. We have 3 lines here, so if I start shading, this is going to get really kind of complicated. There's a lot of different shading. So one thing you can do is just kind of mark it. So like what I might do is come through here and be like, okay, it's a less than. So like for this line, it's going to be everything below. So maybe I'll just kind of draw some little marks, just show myself I'm going to shade under. For the next one, y greater than x would start at 0. Slope would be up 1 over 1, up 1 over 1, and this one is a dashed line. So we get this diagonal line going through like this. It's a greater than, so that would be everything shaded above. So it'd be like going this way here. So you can kind of already get an idea of like where we're going. Like, okay, it looks like so far they overlap in this area here. You know, this is where it gets a little, you know, there's like too many marks, so it gets a little complicated. So I'm gonna just get rid of some of that. So we know it's basically above this line and below that line. So I'm looking at like everything in here. Our last line is just a horizontal line. So it's a horizontal line at 1. It is a solid line. And everything less would be below it. So it should be just kind of like everything in this whole area can't go above that line. Like everything in here would be where I would shade in. This would be my feasible region. This is where all the answers are. So if I pick any point in here, like, I don't know, let's pick like -3, -1. That would be an answer that would work for all 3 of these. And feel free to plug those in and make sure they work. All right, so again, another unbounded because there's no limit here, just keep going this direction. So unlimited answers, basically. Let's look at a bounded one. So this one here, the first one starts at 5, goes down 4 over 3, down 4 over 3, should be a dotted line. This one would shade below, so I'd be looking at everything this way here. The next line starts at -2, goes up 1 over 1, up 1 over 1. It's a solid line. Everything greater, so it'd be above the line. So I'm kind of thinking, okay, I got my answers all in this area here, this section. There's one more. If you just have a y, it's a horizontal line. If you just have an x, it's a vertical line. So a vertical line through 1, and it's a dash line. And it says greater, so greater would be to the right, everything positive. So it looks like we would have everything in this combined area right in here. So everything in this little triangle, actually. This is where all the answers would be for everybody. Less than the blue line, greater than the pink line, greater than my vertical line here, so everything in here. So this would be bounded. There's only, I mean, there's still a lot of answers, you know, like all these points in here, but there's like, it's kind of limited. Only these answers work. Feel free again, by the way, also I should mention this, to pause it and try these yourselves. I'm just going to run through them though. So this one starts at -3, up 4/5, puts me here, solid line, everything greater, so I know it's going to be above this line here. My next one starts at 2, goes down 2/3, down 2/3, it's a dashed line, less than, so I know I'm looking at everything in this section so far. And then I draw one more line, this vertical line through 0, and it's greater, so now I know it's going to be everything in this triangle, another bounded example, and all that good stuff. So everything inside here. All right, so if I pick any point in here, it should satisfy all three of these. All right, let's talk about a couple word problems here. This was nice that they kind of graphed it because we're going to have the prettiest numbers, but we'll work with it. And we'll see like what are some possible answers. So feel free to pause to read through the problem, but you basically have $19.50 for each adult and $11 for each child. They're hoping to get, the operating cost they have to cover is $27.50. So hopefully what the money they bring in is more than $27.50. So this is one equation, all ties into money. The other one ties into like total like capacity here. Looks like it has a boat capacity of 600, including the 8 crew members here. I don't like the wording there, but basically it's adults plus children plus the 8 crew members has to be less than or equal to 600. They can't go over 600 passengers. Okay. What I really would just do here with this equation is minus the 8, so now you just have your 2 variables. So here's your 2 equations, and we want to graph those. One of the easiest ways would be to look for x and y intercepts. Remember, plugging in zeros. Like if I plug in a 0 for A, then C equals 592, and vice versa. If I plug in a 0 for C, then A is 592. So you notice like they plotted a point here around 592, and then 592, and then just connect the dots. Okay, 2 points, then you draw a straight line. So that'd be one thing, and less than would shade below, so somewhere in possibly everything in here. The other line, I would do the same thing because it's difficult, to plot with a slope on this one. But like if you plug in a 0 for A, that would wipe this out. So just do 2750 divided by 11, and that'll give you your child y-intercept. So it'd be somewhere around here, like 250 or so. And same thing here, plug in a 0 for C, divide by the 19.5, that'll give you your x-intercept. So you got those 2 points. This one's a greater than, so our answers should be everything in between here. Should be all these answers in between these 2 lines. And then we just look through these choices, see which ones work. So viable means it's in the shaded region here, or it's on a solid line that borders the shaded region. So go through each point and feel free to double check it. But like 60 adults, okay, that's somewhere, or let's see where they count by 50, so somewhere here. And then 100 children, that looks like it's just slightly below the line. Okay, so I'm gonna say non-viable, or maybe it's on the line, but it's dotted. That doesn't count either. But 210, so 210 adults, okay, somewhere in here, and 350, that should be fine. That should be inside that shaded region. So that'd be viable, that would work. And just go through and check each one. Here, we got to graph it ourselves. Again, some intercepts are going to help out, but again, pause it if you need to check your what it's talking about. But they want to they raised $1,200 to buy livestock for this here thing, so they can sell the alpacas for $160 for each alpaca, $120 for each of these. This is actually going to be less than or equal to $1,200. So if they sell different amounts, the most they raised was $1,200. The number of alpacas plus the number of sheep has to be more than 8, though. They want to donate at least 8 animals, so hopefully more. This one would be easy to find your x and y intercepts, just like start at 8 for each one. So an 8 here and 8 there, draw the points. This one, again, I just plugged in zeros is all I did. So if I plug in 0 for the S and divide by 160, I get my alpaca x, in this case the x-intercept, at 7.5. And vice versa, if I plug in 0 for the A and solve for S, you get 10. So it starts up here at 10, goes down to 7.5, and drew the line. For our red line, it was greater than, so I want to be above this line, but below on the other line. So all my answers should be in this section here. everything in here. It's hard to shade on my laptop, but you get the idea. And then we just look for which ones actually work. Like 0 and 10 works because these are equal to. So I know 0 and 10 is right on the line, but it's a solid line, so that counts. 1 and 8, so 1 and then 8. Yep, that's inside there. And 3 and 6, those should all work. The other ones are outside that shaded region.